Okay, so I'm redoing this because the previous PowerPoint uh, kind of messed up. Timing was off, it looked like. So, and I figured a better way to do it anyways. So here's what this. So I'm doing naming alkanes first, and you're given a structure, and what you have to do is come up with the names. And what I'll do is I'll go how you come up with the names. All right, so you have this structure. What you always do is find the longest chain. Uh, this is it right here, straight across. And so it'll be a propane. Okay, and then it has a side group here, methyl, coming off of it. Again, what a real good plan is actually just to not look at the H's, okay? So you just C to C to C to C. Okay, so longest chain goes straight across. It could also be here, okay, or here. But usually what you do is you just, if there's more than one option, just typically if you just go straight across, it'll give you the best one. So this is propane. Propane has, so it has three, and has a methyl coming off. And the carbons, we number the carbons in a propane, it'd be 1, 2, 3. So the methyl comes off in number 2. So we would say it's 2-methyl propane. Um, since the methyl could only come off in number 2, if methyl come off in number 1, it wouldn't be. It would just be butane then. So technically, you could just leave the 2 off. But let's make sure we put the 2 on it, just so that we don't get mixed up here. Right, the second one, find the longest chain. Now, if you go straight across, that's going to be wrong. Okay, it turns out you can get, that's propane. You can get a butane out of it. So what you could do is you could go down, over and down. Okay, for alkanes, you can twist and turn and go up and down and sideways to get the longest continuous chain. So I'm going to just go straight down a clover, and that would be a butane. Okay, right, and so call it butane, and then there would be the methyl. Okay, if you go from left to right, it comes off number 2. If you start from here, it comes off with number 3. So we're going to start this direction. So it's going to be 2-methyl butane. All right. So next one. So find the longest chain. And it's going to be straight across. If you go down like this, it won't give you the longest chain. So if you go straight across, it's 1, 2, 3, 4, 5, 6, 7. So it's a heptane. And it has an ethyl coming off of it. And going starting here or here, going left to right or right to left, it comes off in number 4. 1, 2, 3, 4. Or 1, 2, 3, 4. So it's 4-ethyl heptane. Okay, the next one. The longest chain, there you also just leave off the H's. So it'll be 1, 2, 3, 4, 5, 6, 7. Okay. Turns out you could go this direction too, but it'll give you the same answer. All right. So go straight across. That's a heptane, and then it has a methyl and an ethyl coming off of it. Okay. We got to pick smallest numbers. If we go left to right, it would be 4-methyl, 5-ethyl. From right to left, it's 3, 4. So I'm going to go right to left because that'll give me the smallest numbering. Okay, so the answer would be, so we have 3-ethyl, 4-methyl, and the ethyl becomes 4-methyl because of the alphabet, so it's going to be 3-ethyl, 4-methyl heptane. Okay, it's not the numbering that determines which one goes first. Okay, if ethyl would have come off at number 4, ethyl still would have been first. It might have been 4-ethyl, 3-methyl. Okay. All right. Okay, next one. 1, 2, 3, 4, 5, 6, 7, 8. Straight across. Let's see what happens if we go up and across. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. So it also gives you 8. So I'm just going to stick going straight across. Like I said, if you get it more than one way, it's probably going to just going straight across give you the same answer. So this is an octane, and it has a methyl and a propyl. Okay, now what you have to do is number. So going from right to left, it'd be 4, 6. But going from left to right, it's 3, 5. So we're going to go left to right. So methyl become before propyl because M is before P in the alphabet. So it's 3 methyl, 5 propyl octane. Right, next one. Okay, longest chain. 1, 2, 3, 4, 5, 6, 7. Okay, and so it's heptane. And it has 3 methyls coming off of it. So it's trimethyl. And the numbering, if you go left to right, it's 3, 3, 5. If you go from right to left, it's 3, 5, 5. So we're going to go left, right. So 3, 3, 5. Okay. Trimethyl, because there's 3 methyls. And finally, last one on this page is the this structure right here. It's a butane, and it has 2 methyls coming off of it. And the numbering will go right to left because they come off number 2. If we went left to right, they'd be 3, and we get smaller numbers going right to left, so 2. So it's 2,2-dimethylbutane. All right, now this common mistake that students make is for some reason they don't leave off one of the 2's, and would just say 2-dimethylbutane. All right, you have to tell where all the methyls come off of. So in this one up here, we had to say 3, 3, 5. This one you have to say 2, 2-dimethyl. Okay, so even though they come off the same carbon, and it might seem redundant to say 2 twice, okay, you have to say it. All right, continue on. Okay, so next one, it's a propane, 3 carbons, and it has 2 methyls coming off of number 2. And again, it's 2,2-dimethylpropane. Don't forget that second 2, all right? All right, next one. 1, 2, 3, 4, 5. So it's going to be a pentane. There's ethyls, 2 ethyls coming off of number 3, going either way. So this can be 3, 3-diethyl. And don't forget both 3's. All right, next one. Okay, now if you go straight across with this one, you get the wrong answer, okay? So the longest chain goes like this, so it kind of sweeps back. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so it's going to be a decane, and then it has a ethyl and a methyl coming off the chain. Now you have to decide what the numbering is. If you start up here, the numbering would be 1, 2, 3, 4, 5, 6. So both of these would be 6. But if you start on the bottom carbon, 1, 2, 3, 4, 5, these will both be 5. So it'll be 5 ethyl, 5 methyl decane. All right. So you don't go 5, 5 ethyl methyl. All right. You have to go 5 ethyl, 5 methyl. All right, next one. Okay, so you can see this one kind of goes all over the place, and so you have to be careful. It's not going to be straight across. I believe it's going to be like this, okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's nonane. Okay, and it has this coming off, and has an ethyl coming off here, and a methyl coming off here. Okay, so it's going to be ethyl, methyl. Now I have to figure out the numbering. So if this is number 1, they would be 4 and 6. If you go from here, they would be 1, 2, 3, 4, and 6 as well. So I guess it doesn't matter which way you go here. It would be 4 ethyl, 6 methyl nonane. All right, next one. Okay, so find the longest chain. You see it's this, okay? You could try different ones, but got to find the longest chain. So 1, 2, 3, 4, 5, 6, 7. If you went up here, it'd give you 6. So go across, so it's 6. So 1, 2, 3, 4, 5, 6, 7. So it's a heptane. And then it has an ethyl, and it comes off for number 4 either way. So if we start here, 1, 2, 3, 4, 1, 2, 3, 4, they both give you 4 ethyl heptane. All right, last one. 1, so the longest chain is straight across. 1, 2, 3, 4, 5, 6, 7, heptane. Has 2 methyls coming off. And the numbering, if you go from left to right, it'd be 4, 6. 1, 2, 3, 4, 5, 6, dimethyl. If you go right to left, it's going to be 2, 3, 4, 2, 4 dimethyl. So we're going to go from from right. Okay. Now we're going to go the other way. Structure to name. Name the structure. Okay. So 4-ethyl octane. So you write the longest chain out. 1, 2, 3, 4, 5, 6, 7, 8. And then you put ethyl coming off at number 4. Either direction you can pick. I picked it from left to right. 1, 2, 3, 4. And then you put the ethyl here. Okay, next one. 2-methylnonane. Okay, by the way, you could put a dash between the ethyl and octane, or the sometimes I leave it off, sometimes I put it there. So I'm not gonna take any points off for doing one way or the other. So 2-methyl nonane, 1, 2, 3, 4, 5, 6, 7, 8, 9, and a methyl comes off number 2. Okay, you could have done it down here too. It could be the same answer. So 2-methylnonane. Right, next one, 3,3-dimethylpentane. 1, 2, 3, 4, 5. Okay, so 1, 2, 3, 4, 5. Okay, and then you have 2 methyls coming off number 3. Right, that's one here. 3-ethylpentane. 1, 2, 3, 4, 5. And ethyl coming off of number 3. Okay, next worksheet, more naming alkanes worksheet. All right, so you have we give you the structure to figure out the name. So find the longest chain, 1, 2, 3, 4. So it's a butane, and it has a methyl coming off number 2. Okay, going right to left. If you want from left to right, it'd be number 3. So going right to left, they'll give you a smaller number. So it's 2-methylbutane. Okay, next one. The structure here has 4 carbons. So it's a butane, and there's methyls coming off of the chain. Either direction will give you the same answer. So it's going to be 2,3-dimethylbutane. All right, next one. So, okay, got to be careful with this one. If you go straight across, you get the wrong answer. So longest chain would be 1, 2, 3, 4, 5 pentane. Okay, and it has here and here is a methyl. Okay, if we started from this carbon, it'd be 3, 4 dimethyl. And if we start from this carbon, it'd be 2, 3 dimethyl. So going from this carbon over, it'd be 2, 3 dimethyl pentane. All right, here we go. Okay, so there's this longest chain. You could also get it like this. To may give you say no, it doesn't. So straight across gives you the best answer, does it? Right, got a little confused on this one. So turns out this is going to give you the longest chain. 1, 2, 3, 4, 5, 6, 7. If you go straight across, it's 6. So here's the longest chain, so it's a heptane, and you got this hanging off of it. Okay, either direction, if you start here, 1, 2, 3, 4, or if you start here, 1, 2, 3, 4. So both directions will give you 4-ethyl heptane. All right, next one. Okay, here's the longest chain. 1, 2, 3, 4, 5, 6. So it's a hexane. And it has 2 ethyls coming off in number 3 and 4 either direction. So 3,4 diethyl hexane. And last one on this page, 1, 2, 3, 4, 5, 6. So it's a hexane with a methyl coming off in number 3. Okay. Okay, so now what we have is names, and we'll go to structure. So this is 2,2,4 trimethyl. So 1, 2, 3, 4, 5 pentane. And it comes off number 2, 2, and 4. Next one is 2,3 diethyl 4 propyl octane. So 1, 2, 3, 4, 5, 6, 7, 8. 2 ethyls coming off of 2 and 3. And number 4, the propyl. Okay, so this is the structure you get. Turns out that actually this is the wrong name for the structure. Okay, if you were to be given this on the test, you would go ahead and draw it and tell me that it's a wrong structure, the wrong name. The right name, the longest chain starts actually up here. So it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9. So this would be a nonane with a methyl, ethyl, and a propyl coming off of it. But all you have to do is tell me, draw it, what it says, and tell me it's the wrong name. Okay, and the last one is 3,4 diethyl 2,2 dimethyl 3 propyl decane. So here's decane. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Tells me I have 2 ethyls coming off 3 and 4. So 1 and 2. There's 3 carbon 3 and 4. There's ethyls. There's 2 methyls coming off of number 2. Okay, and then a propyl coming off of number 3. Okay. All right. Again, this is actually the wrong name of the structure. So again, what you would do is tell me that draw the structure out that gives you and tell me it's wrong. The longest chain actually is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So, and you wouldn't have to name this. Okay, just tell me it's the wrong structure. Draw it and tell me it's the wrong name. All right, cycloalkanes. Okay, so cycloalkanes, we draw these geometric structures to represent these carbons, hydrocarbons. At each point there's a carbon, and each carbon has 4 bonds. So all cycloalkanes have twice as many hydrogens as they do carbons. So coming off of each one of these carbons is 2 hydrogens. Okay, so this carbon right here would have 2 carbons attached, and then I have 2 hydrogens. Okay, this has 9 points on it, so this is cyclononane. The chemical formula would be C9H18. Right, next one over, 2-ethyl-5-methyl. Okay, this is what they give you. It's a Cyclo Pentane. You always start with the longest chain, propyl. Okay, and then you're given 2 directions. Okay, you go the direction that'll give you the smallest number for the next largest chain, or ethyl. So we're going to go clockwise. So this is 1, 2, 3, 4, 5. So it's going to be 1 propyl, 2 ethyl, 5 methyl. Now the ordering, E before M before P. So 2 ethyl, 5 methyl, 1 propyl. Okay, Cyclo Heptane. Okay, yeah, 7 points. So 7 is hept. All right, next structure. This is also a Cyclo Heptane, and it has ethyl and 2 methyl. Start with the longest chain, give that a 1, and then give the direction that gives you the smallest numbers. If you go counterclockwise, it'd be 1, 2, 3, 4. Be 1, 4, 6. If you go clockwise, it'd be 1, 2, 3, 4, 5. 1, 2, 5. Okay, so we're going to go clockwise. So the ethyl, 1 ethyl, 2, 5 dimethyl cycloheptane. All right, the next one, you have the all right, so this is a cyclonone. It has 9 points. It has 2 ethyls and 2 methyls. Okay, it takes a little bit of figuring out, but you want to give the ethyls the smallest numbers if it's possible. So I'm going to start here and go clockwise. So it'd be 1, 3 diethyl, 5, 7 dimethyl cyclonone. All right, next one. This is a Cyclo Heptane, has 7 points. It has 2 methyls coming off of it and an ethyl. So there's 2 groups coming off the same carbon here. So we're gonna have to so they'll get the same numbers. So we'll start here. This is 1, and going counterclockwise. So 1, 2, 3 gives me a 1, 1, 3. 1, 2, 3. 1, 1, 1, 1, 3. Going the other way clockwise gives me a 1, 1, 2, 3, 4, 5, 6. Sorry, 5. So it'll be 1, 1, 5. So I'm going to go counterclockwise. So this one is 1 ethyl, 1, 3 dimethyl cycloheptane. All right, next one. This is cyclobutane. It's a square. There's carbon coming off each of these points. And there's 2 propyls. It doesn't matter where you start. We'll call this number 1, 2, 3. So it'll be 1, 3 dipropyl cyclobutane. Okay, this is cyclopropane. Has 2 methyls. So it'll be 1, 2 dimethyl cyclopropane. And finally, you get 1. So it's cyclohexane with a diethyl coming off. Ethyls coming off of number 1, and you can pick either one as number 1. So I'll say this number 1, 2, 3. So 1, 3 diethyl cyclohexane. All right, last ones of naming. So alkenes and alkynes. So we give you this structure here. It's an alkene because it has a double bond in it. Notice with the chain is kind of zigzag, and you can kind of ignore the hydrogens. So 1, 2, 3, 4, 5. So it's a pentene. Okay, the numbering is determined by double bond, not by the side groups. And what you want to do is you want to give the number to the double bond that gives you the lowest number. So if you start here, the double bond comes after number 2. If you start this direction, it comes off at number 3. So we're going to go left to right. So this is going to be a 2 pentene. I'll write that down first. And then it has a methyl coming off at number 2 as well. Okay. Next one is also alkene. 1, 2, 3, 4, 5, 6, 7. So it's a heptene. The double bond comes off the second carbon going right to left. Okay, that's the direction. It'll give the smallest number. So it's 2 heptene. Then it has 2 methyls coming off, right? And we're going right to left. So one comes off 2, one comes off 3. So it's 2, 3 dimethyl 2 heptene. Right, next one. And this one's a little confusing. But again, so this could be a bond right here. So you could start here, 1, 2, 3, 4, 5, or you could start here, 1, 2, 3, 4, 5. Okay, so it's going to be a pentane. And so I'm going to go like this. It's my longest chain right there. Okay, what carbon does the double bond come off? If you go left to right, it goes off to number 2. If you go right to left, it comes off of number 3. So I'm going to go left to right. So 2 pentene. And then it has a methyl coming off of this carbon right here. So it comes off of 1, 2, 3, 4. So 4-methyl 2 pentene. All right, and the last one of the structures. This one is 1, 2, 3, 4, 5, 6. Hexane because of the triple bond. Okay, and what number does it come off of? 1, 2, 3. So from left to right, it comes on number 3. From right to left, it comes off of number 3 as well. So it looks like it doesn't matter which direction. It does matter because you want to make sure the methyl goes on the smallest number. If it went from right to left, so it's going to be 3-hexane, but if you went from right to left, it'd be 5-methyl. Okay, but instead we want it to have it smaller, so it's going to be 2. And the last one of these, of the structures, given a name, here's butane. 1-butene. So on the test, if I ask you this type of question about alkenes and alkynes, I want you to include hydrogens. You don't have to write the hydrogens. You can write a dash to represent the hydrogens. So I've actually showed where all the hydrogens can be here. So this is, so notice each carbon has 4 bonds. So 1-butene. The other thing, just a side note, is the structure of each one of these carbons has a certain shape. If a carbon has 4 single bonds, it's tetrahedral. This carbon here has 3 attachments, so it's not going to be tetrahedral. It's going to be trigonal planar. So it turns out that all the alkenes, the carbons involved with the double bond will always have a shape of trigonal planar. But the 4 single bonds will always have tetrahedral. So all the alkanes have tetrahedrals, but the alkenes will have trigonal planar where their double bond is. Okay, next one. 3-methyl 4-propyl 3-octane. So I'm going to draw octane. 1, 2, 3, 4, 5, 6, 7, 8. Put the double bond at number 3. Make a methyl coming off number 3, and a propyl coming off number 4. Again, notice all my carbons have 4 bonds. Okay, this tetrahedral, tetrahedral, trigonal planar, trigonal planar, tetra, 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 tetra. Okay, and the last one, 5-ethyl, 2-methyl, 3-heptane. So 1, 2, 3, 4, 5, 6, 7. It's ine, so there's a triple bond coming off of number 3. 1, 2, 3. There's a methyl coming off of number 2, and an ethyl coming off of number 5. Okay, now actually the shape around these guys is linear. See it, the carbons involved with the alkynes will be linear. They have 2 connections and no lone pairs. So this is a linear shape. So it'll be trigonal, trigonal, linear, linear, trigonal, 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 and so forth. Okay. So what I'm going to do is split this review up into 2 parts. One PowerPoint and then another PowerPoint. Okay. I think. All right. That's all for now. All right. So I decided to continue with this because the other one is messed up. So now I want to go over to cis trans and understand it. At least try to get some sense of it. All right. If this was a single bond right here, so if we got rid of this double bond, put a single bond right here, what we could do is we could twist this carbon so that this Cl is on the bottom, okay, and this H would be on the top. And so what you could do is you could twist this structure to be exactly the same as this structure here. But what the double bond does, the double bond locks in that, so you can't twist it. So these two structures are not the same, okay. They have basically the same name. They both are, and you don't have to name this, but they are 1,2-dichloral we call these chloro, so 1 and 2, and it's an ethene. Well, this also is a 1,2-dichloroethene. Now, they aren't the same, though, because of this arrangement of the chlorines on different sides. So what you have to do is you have to add another part to the name. So if these, and we'll see down the road a couple more examples, but what you do is that if you have the double bond, you kind of just draw a line through the double bond like that, and then if the groups are on the same side, we call that cis. Cis means same, and you probably heard it out there. Cis, sexual, transsexual, and all that stuff. So cis. So this one would be cis 1,2-dichloroethene. Okay, and you don't have to name that. You just have to tell me that this is cis. All right, now this guy here, if you draw a line, the chlorines are on opposite, so they're on opposite sides or cross sides, and we call that trans. So on the opposite sides, they're trans of the double bond. Right, let's take a look at this example, and what I want to know is if these two are the same structure, and if they are not the same structure, which one is cis and which one's trans. Okay, so they would have the same name, 1, 2, 3, 4, 5. So pentene, that'd be 2 pentene. This one has a 2, 1, 2, 3, 4, 5, 2 pentene. Okay, but notice is that if you draw a line through here, that they have a CH3 and this guy are on the opposite side, and over here they're on the same side. So these are not the same structure. Okay, so we have to name one cis and one trans. This is the cis version because these are on the same side and these are trans. Right, take a look at this guy. Now this guy here, draw structure through here. So now let's say I draw another structure that looks just like it, I move this H up here and this H down here. Well, it'd be exactly the same structure, okay? So one way to tell that if you have, not all alkenes will have cis trans. So this is one that does not have cis trans. And one way to tell is if the carbons that are involved in the double bond, if either one of them has the same thing coming off of them, then it will not have a cis trans. Okay, notice this carbon here has a CH3 and a CH3, so the same thing. So I know right off the bat this won't have a cis trans. Or this one has H. So this one double. All right, let's take a look at this one. Are these guys same or different? Okay. So notice, so one way to tell that different is if the carbons involved, okay, have different things attached to it. All right. So this double bond carbon has different things attached to it, and so does this one, and so this definitely has a cis trans. Okay. So maybe I would give you this and ask you to draw the other version of it. Tell me that this is the trans version, and then you would draw the cis version like this. Okay, so now let's take a look at this structure here, these two structures. Are they the same or are they cis trans? Okay, one way to tell is look at each carbon, and if the carbons have either one of the carbons have the same thing attached, then they will not be cis trans. So notice this carbon here has hydrogens attached. So even though so even though these guys are flipped, compared to this one, all we did was we turn it upside down to get this. So this will not be a cis trans, and that's because one of the carbons, at least one of the carbons, has the same things attached to it. All right. Next thing I want you to know is I want you to know a couple reactions that have to do with alkenes. The first one is called hydration, and that's where you take alkene and you add water to it. And what happens is the water, the H of the water, so the double bond disappears, and an H attaches to this carbon here, and an OH attaches to the other carbon, like this. When you draw this out, don't go CHO. It's COH. Notice the double bond's gone. All right, so this is a way of getting rid of the double bond. Hydration means adding water. Add water. Okay. So hydration 2-butene. So draw butene 1, 2. This should be 2-pentene. I'll change that in a second. So hydration of 2-pentene. So draw the 2-pentene, and then add the water across the double bonds. Include all the hydrogens. When you do this. And they could just be dashes. That's fine. All right. The next type of reaction is hydrogenation of 2 pentene. In this case, what you do is add H2. I'll write it as HH. What happens is it breaks the double bond and the 2 hydrogens attached to the carbon. Notice here that what happens is that this actually turns an alkene into an alkane. So it turns an unsaturated hydrocarbon into a saturated hydrocarbon. And we'll see a similar thing when we talk about fats, saturated fats and unsaturated fats. So you have to know in these two reactions. I might say write the chemical reaction for the hydration of 2 heptane. So you draw 2-heptane, have the HOH plus. It's not equal, by the way. It goes to. So and then the H could go to either this carbon or this carbon. The OH goes to the other one. Get rid of the double bond. So notice there's no double bond here. Know this reaction too. I might have said what is the hydrogenation of 2-heptane again. So you draw a heptane with all the H's, the H, and show how this goes in here. I'll go over a couple other things here, so that you have to know for the test. So I'll go over a couple other things you have to know for the test here. You may be given a problem like this where you have to tell me, I'll give you this, and then I'll ask you cross out the atoms that have the wrong bonding. All right, and so carbon gets 4 single bonds, no lone pairs. Nitrogen gets 3 single bonds, 1 lone pair. Oxygen gets 2 bonds, 2 lone pairs, and hydrogen only gets 1 bond. All right, I'm leaving off some of the bonds, single bonds, but that's fine. So let's look at each one. So that you have this carbon here, and I'm going to switch over to a pen. All right, hopefully this works out. So I'm going to look at this carbon here, and this carbon here has 1, 2, 3 bonds, so this is a bad carbon. This hydrogen and this hydrogen both have 1 bond, so they're both good. All right, this oxygen, this carbon here has 1, 2, 3, 4 bonds, so that's good. This oxygen has 2 bonds, but it's missing its lone pairs, so it's not good. This nitrogen has 3 bonds, 1, 2, 3, and 1 lone pair, so it's good. And this hydrogen has 1 bond, so it's okay. This oxygen has 2 bonds and 2 lone pairs, so that's good. This hydrogen's horrible. It has 2 bonds. Okay, this carbon has 1, 2, 3, 4 bonds, so it's good. This hydrogen good. This nitrogen has 1, 2, 3 bonds, but it's missing its lone pairs, so it's not good. This oxygen has 2 bonds, 1, 2, and 2 lone pairs, so it's good. This nitrogen has 1, 2 bonds, so it's bad. It needs 3 bonds. This carbon here has... Okay, now you saw something like this in the first PowerPoint, talking about the basics of this class. And what I ask you to do is figure out, and you might see something like this on the test, is the circled atoms, what are their shapes. Okay, so this atom here has three connections and 1 lone pair, so it's going to be trigonal because the lone pair is pyramidal. Okay, this carbon has 4 connections, so it's tetrahedral. This carbon has 3 connections, 1, 2, 3, so it's going to be trigonal planar. Notice the difference between this carbon and this nitrogen out here. They both have 3 connections, but this has a lone pair, which makes it pyramidal. And then finally, this carbon has 2 bonds and 2 lone pairs, so this is going to be bent. Okay, and the last thing is knowing the macromolecules and their building blocks. Know what biological macromolecule means, okay? And that's in the first PowerPoint. And here's our 4 macromolecules to cover and the building blocks. And there's 2 main themes that we'll cover in class. Is 1, structure leads to function. 2, building blocks make big macromolecules. All right, so that's the review for this test.